6.2, the first day, and we're still dealing with the exponents. We're not doing all the properties of multiplying the exponents, taking them to powers, dividing and negative exponents. Instead, we're going to look at this from a graphing standpoint. And we have different kinds of graphs. We have exponential growth and we have exponential decay. And looking at these graphs, these are examples of exponential graphs. When you were in your first section of Algebra 1, you had lines. We call those linear graphs. That's just like when y equals 3x plus 2. There's no exponents. There's nothing squared. It's nice and linear. It makes a line. Then you got into parabolas, stuff that might look like this. That's if you have x as your base and it's just to the second power. You can add other things with it, but this would be a parabola. Now we're looking at exponential graphs. So it's not going to have this kind of an equation. It's not going to have this kind of an equation. It's going to be when your base is some number, maybe 2, maybe 0.2, and your exponent is x. So notice how these two are not the same, but they are kind of similar to each other. They're going to give us different graphs as well. As I look at letter A, I'm trying to determine whether it's not exponential growth or exponential decay. Based off of what we know about reading graphs, which is read them from left to right, is this graph growing or decaying? Growing. So this would be exponential growth. It's getting bigger. Letter B, what would you say about this one? Decay. It's getting smaller over time. And notice the way that this goes to the right, it doesn't look like it's going down really steep. Eventually, it's starting to level off. And usually there's going to be some kind of a horizontal asymptote that it's starting to approach. It's not going to go down forever towards negative infinity. And then in letter A, as I go to the left, again, it doesn't go down forever. It's going to start leveling off towards the left. All right, one more in this set, letter C. Would we call this one growth or decay? Growth. It is getting bigger. This is exponential growth. So by looking at the graph, we should be able to determine if it's exponential growth or decay. The next 6 examples don't have graphs for us, so we have to look at the equation to determine what it is. I'm going to bring up my graphing calculator and graph this first one. So y equals 3.2 parentheses 0.9 to the x. If you have a graphing calculator, you can put it in exactly like I did to see what this graph looks like. So here's the equation. I'll just make a quick check. 3.2 times 0.9 to the x. And then if I hit graph, it should show me the graph. I'm not sure if my zoom is correct. So if I hit zoom 6, which is zoom standard, this should give me a really good graph of what we're seeing here. And there it is. There's my graph of y equals 3.2 times 0.9 to the x. So as you look at this one, would you call it exponential growth or decay? Decay. And after we've done a few of these examples, we're not going to look at the graph again. We should be able to look by just at what the equation is to know if it's going to be growth or decay. So I'll do a couple more here. Here's the second one. It's 0.35. So y equals 0.35 times, and it was 1.98 to the x. So 1.98 parentheses to the x. So this is what my equation is. Now I'll go back to the graph. I don't have to hit zoom 6 again because my graph has a nice viewing window. So here it's starting to move a little bit. Now I can see something happening. What would you say about this one? Growth or decay? Growth. Again, my goal is to look at the equation, not have to graph it every time. So can you start to make some generalizations? Let me be quiet for a second and give you a chance to think what you notice, why this one is growth or decay, why this one is growth, and make a prediction on the next one. All right, so hopefully you made your prediction. Let me go back to the equation. It's y equals 9. So let's clear this one. 9 parentheses, 5 halves. If I do alpha y equals n over d, so there it is, 5 over 2 to the x. Here's the equation we were given. Here's the graph. All right, so what do we have in this one? Growth. Growth. All right, so there's another example. I'm going to have you, again, predict. Here's letter G. Here's what the equation is. Make your prediction. And what do we think? Is it the number out front that's determining whether it's growth or decay? No. It's the number on the inside, right? So we're looking at this 8/11ths. Is that going to make it growth or decay? Decay. Letter H, you're looking at the 42. Growth or decay? Growth. And letter I, it's 0.15. Growth or decay? Decay. So the question is, why is it growth? Why is it decay? We're always looking at that number on the inside. What are you comparing this number? I'm highlighting them all in green. What are you comparing that with? 1. If this number on the inside is less than 1, like 0.15 or 0.9 or even 8/11, that makes it decay. If the number on the inside is bigger than 1, that's going to make it growth. Notice all of these green numbers are positive. They're never going to be a negative base in there. And you're comparing it to 1. If the number is less than 1 but greater than 0, it is going to be decay. If the number is bigger than 1, it's going to be growth. 2, divide each y-coordinate by the previous y-coordinate to find the growth or decay factor for each exponential function. Then circle whether the table represents exponential growth or decay. One thing I need to notice in this is all of these x values increase by 1. So if I were to graph this, I do 1, 3, and then over 2, 6, over 3, 12, 4, 24, 5, 48. It looks like it might be exponential growth because it is getting bigger. But I'm not sure because maybe it's a part of a parabola, or maybe it is this exponential growth that we're looking for. So to figure out for sure, we have to do some division. I'm going to start at the very far side, and on your calculator, I want you to take 48 divided by 24. And then take 24 divided by 12. Then take 12 divided by 6. Then take 6 divided by 3. Did we get the same answer every time? Yes. Yes. So the growth or decay factor is 2. That makes it exponential growth. So we find the number by going from right to left, but if you look left to right, each of those numbers is really getting 2 times bigger than the previous one. So it's exponential growth with a factor of 2. Next one, and I'm looking at my top row. It's just a really quick observation. These numbers should all be going up by 1. If for some reason they don't, you might be like a bit of a trick question. If they don't go up by 1 every time, we have an issue. But now we're going to check the bottom row again. Take 1/9 divided by 1/3. Go ahead and try that. So I have 1/9 divided by 1/3. Did it come out to 1/3 on your calculator, or 0.3 repeating? Yes. Then take 1/3 divided by 1. Well, that should be easy. What is anything divided by 1? 1. Itself, right? So 1/9 divided by 1/3 was 1/3. 1/3 divided by 1 is 1/3. What's 1 divided by 3? 1 divided by 3. Isn't that 1/3? What's 3 divided by 9? 1/3. Did we get the same number every time? Yes. So it is exponential. Our factor is 1/3. Does that make it growth or decay? Decay, because this number is less than 1. If you haven't picked it up yet, calculator is really important on these, especially as we get into some nasty numbers. Maybe for those first 2 problems, you were okay without a calculator. And this one, I'd say definitely use your calculator and check again. Take your last number, divide by the 1 right in front of it. Go ahead and try that. Once you do that, then take the next number, divide by the one in front of it. And we're looking to compare the number to see if we get the same ratio or the same result every time. If even one of them is off, then it doesn't work. But did you get the same number every time?
No.
Yes, no?
No, I did not. When you round up, yeah.
Was it exactly the same, Rogue? What was it?
I just like did not get that.
So 1.25, take 1 divided by the previous one, we get 1.25. So that is our factor. Is that growth or decay?
Growth.
Growth, isn't it? Because the number is bigger than 1.